All right, so we've seen how amazing it is that the derivative of x to the n is n x to the n minus 1 if n is a natural number, right? This says n is an element of the natural numbers. Remember, the natural numbers are 1, 2, 3, 4, 5. Positive integers. I guess we could just say that, positive integers. All right, but here's what makes it even better. We proved this using Pascal's triangle. What we are not going to prove in this class is that, in fact, the derivative of x to the a equals ax to the a minus 1. Now, I really have not written anything different, just changed the variable. But the reason I changed the variable is because now I'm going to say a is any real number. All right? Now, to prove that actually requires a lot more work. You have to prove that the derivative of exponent, e to the x is e to the x, and then show that any exponent can be written in terms of e to the x. That's something, it's not totally undoable, but it's not a rabbit hole that we're going down today. So here is why it's amazing, especially when you remember, all right, that the nth root of x can be written as x to the 1 over n. This is just a little algebra 2 review right here. The nth root of x to the m is equal to x to the m over n. 1 over x to the n can be written as x to the negative n. And 1 over the nth root of x can be written as x to the negative 1 over n. And 1 over the nth root of x to the m can be written as, Gertie, how do you think it should be written, Gertie? I don't know how to write it. You want to eat my lentils? Is that what you want? You want to eat my lentils? Maybe you should eat my lentils. Get out of there. Come on, Gertie. Should stop eating my lentils. All right, so that equals x to the negative m over n. So all of this is algebra 2 review. If you're unclear on any of that, let me know, but you're going to see some examples here. Okay, so why do these things together with this make this even more powerful? I will show you. What if f of x is equal to the square root of x? Using these ideas, I can say that the f of x is really x to the 1/2 power, and then I can state the derivative using this generalized power rule. So 1/2 is not a natural number, but it turns out, and we're not going to prove it, you can still do the same thing. Bring the 1/2 out to the front and drop the exponent 1. What's 1 less than 1/2? It's 1 less than 1/2. It's negative 1/2, that's right. All right, now, so what we've done is taken the root, write it in terms of an exponent, and then use the power rule on it. So one thing that would be nice is, since the power was given to us as a root, let's write our answer as a root and write this, it's good practice at using these rules. So this is equal to 1 over 2 square root x. So work on seeing how this is actually this, right? That's using this rule right here. Okay, so think about how that works, and rewriting your answer in terms of roots instead of rational exponents is not required generally. However, it's a good thing to be able to do. It's good practice with understanding those exponents. And also, by the way, part of the AP exam is multiple choice. So if you're given this derivative and you figure out that it's this, but then your A, B, C, and D all look like this, you have to recognize that this answer is equal to this answer. All right, let's look at some other ones. What if f of x equals 1 over x squared? All right, what would the derivative be? Well, 1 over x squared is equal to x to the negative 2. So that means that f prime of x is, bring the exponent out front, drop it 1. What's 1 less than negative 2? Is it negative 1? No, it's negative 3. So the derivative of 1 over x squared is negative 2x to the negative 3rd, which I could write as negative 2 over x cubed, right? So using this rule, right? Okay, what else? What are the kind of fun things? What if I had f of x equals 5x to the 4th minus 3 over x cubed? All right, the first thing I would do is rewrite the function because I want to write this in terms of a rational exponent. So this is 5x to the 4th minus 3x to the negative 3rd. All right, and then I'll follow my power rule and say what f prime is. So you have to be careful, like this is f. When I rewrite it, I have not done a derivative. This is still f. When I do the power rule, multiply and subtract, when I do that power rule, now it's not f anymore, it's f prime. So you have to be careful what you're writing where. This is now 20x cubed. Negative times negative is positive, so it's plus 9x to the negative fourth, because I'm dropping this exponent 1 and I'm dropping this exponent 1. Okay? More exciting examples in the next video.